let's take a look at publishing and exporting from ProRaster. I'm running ProRaster Premium. So to start with, I'll just create a new lookup table algorithm. Go to the color component, to the component page. I don't have a raster source, so I'm just going to browse to a raster. And I'm going to choose this magnetics raster data for Australia. So I'll just change the color data transform to equal area. And there's my algorithm. I'm going to save that, so hit save as. I'm just going to put it up here, and we'll call this magnetics algorithm. So we have a MRD algorithm saved. Now to publish, you simply press the publish button. There'll be no questions asked, and it will happen immediately. So publishing is only available with MapInfo Pro. You need to have the latest version of MapInfo Pro, which is currently 2021, and you should have the latest patches to MapInfo Pro installed. And that's because there are some bugs in the MapInfo Pro algorithm rendering code, and I'm working with MapInfo to resolve those, and as they do, they'll be released in patches to MapInfo Pro. So get the very latest. So I'm going to hit the publish button. You have to have MapInfo Pro running when you publish, and when you do, it will open up a new map, and here's that algorithm being rendered in MapInfo Pro. So that's all good, and that's all there is to it. If you want to do that process manually, well, then you just save the MRD file, then you go into MapInfo Pro. Let me bring it up again, and you can go home, open table, then in the drop list here for files, select raster image. So an MRD is loaded via the raster driver. So select raster image, then you'll be able to browse to your MRD file and open it. Or alternatively, you can load it via the tab file. So that's publishing. Now let's take a look at exporting, which is different. So exporting is a processing operation that renders the algorithm out to a located image format, a raster like GeoTIFF, and then you can take that GeoTIFF or whatever format you output it as, and you can load that into a wide variety of different software. So let's have a look at the dialog. Okay, so firstly, it's given me an error. It says the algorithm has not been named. So this is just a little quirk. You do need to have a valid name for your algorithm before you can export. So go to the algorithm in the tree, go to the name, and type in any name for the algorithm. So I'm going to call this Australia Magnetics. And you can see that that name is then reflected in the tree here. The algorithm name is there, and it's the same with the layers. They reflect the data that's the rasters that have been connected to that layer. So I'll just save that. Now we go into the export dialog. So you choose your output format. I'm going to use GeoTIFF and the compression that you want, and I recommend using lossless compression. And then a color format. You can either choose RGB or RGBA. I recommend using RGBA, so you include an alpha band in the output. And in software like QGIS, for example, you can use that alpha band to tell QGIS which pixels are valid and which are invalid. So you need to specify a file name. So australiamagnetics.tiff, that's okay. And then you need to set the extent of the raster that you're going to export. So the first option is a full extent. And you can see down here there's coordinate range. These are not editable unless you select manual extent. And up here you have a raster size, and you can see that we're going to get a raster of 51,200 pixels across and 41,985 pixels high, with a cell size of 3 arc seconds. So I don't want something that's such high resolution. That resolution reflects the actual resolution of the magnetics raster that we're rendering. So I can use this resolution level to adjust the raster size easily. So if I bump that up, that takes me up levels in the overview pyramid. And each level gets 2 times smaller than the level before it. So if I go up 3 or 4 or 5 levels, I get to a smaller raster with a larger cell size, and now I can hit process. So it brings up this dialog and just executes. There are some buttons here. You can see the warnings and the errors and then all the messages that came through. Hopefully you won't see any warnings or errors. If I hit close and now close this, we can just take a look at this TIFF file. Here it is. So I'll just drag and drop it straight into ProRaster. And so here's the TIFF file. You can see it looks like what we started out with, but it's at lower resolution, so we're not seeing the kind of high resolution from the original raster. So let me take that away. Let's go back into the export dialog. Well, this time we're going to use the clip to map option. So if I zoom in somewhere in the preview, and then I go into export and I use clip to map, now you can see that I'm only getting a small number of pixels. So we can bring our resolution down a bit so that we get a reasonable size. And note that this resolution level goes both above 0 and it goes below 0. And when you go below 0, you're going to then be interpolating inside of the original grid cells. So it'll be using things like bilinear or bicubic and so forth to make that interpolation. So let's try this one. So that's all done. Close that again, drop that TIFF file in, and there's our output. As you can see, pretty much looks the same as the original algorithm in this case. So I'll close that one off again. Back to where we were before. Now let me bring up MapInfo. So we have a little polygon here. So here's a simple polygon, and this time we're going to do an export and clip the raster to that polygon. So let's take that out of the way. Bring up the export dialog. This time clip to polygon. Browse to that polygon that I've created. So the polygon must be in a MapInfo table format. So there it's loaded the polygon. You can see the coordinate range has now changed to reflect the size of the polygon. So again, let's choose a resolution level that gives us something reasonable, something like that. Hit the process button. That's all done. Let's close that. And once again, drag in the TIFF file and see what it produced. And there's the algorithm clipped to that particular polygon at a certain resolution. So let's close that off. Now, the polygon, of course, has a coordinate system. So if you put the algorithm into a different coordinate system, so if I change this to projections of the world, for example, popular visualization, or maybe we'll change it to something that really makes a difference, so Moloide, for example, quite different. If I now do an export and choose a resolution level, hit process. This will probably take a little bit longer to process. Close and close. Now if I bring that TIFF in, you'll see that it's now in the Moloide projection. So the fact that the vector wasn't in the same coordinate system as the raster doesn't make any difference. It sorts that out. So let's close that off. Let's go back to just latitude, longitude. So that was just a simple polygon. Let me bring up MapInfo again. I have another polygon here, which is much higher resolution. It's a polygon for the whole of Australia. So this has got multiple polygons in it. lots and lots of parts, millions of nodes, and so forth. So I just want to demonstrate that that's also no problem for this system. So I might just open a different algorithm. I'll go to this global atlas rendering of the world, and this uses high resolution DTMs as well as bathymetry for the whole world. Let me go into export. Perhaps output it to a different file this time. So demonstration globalatlas.tiff. Okay, I'm going to load the polygon. This time I want the Australia polygon. I'm going to choose some resolution level that's reasonable, maybe a little bit more. Now let's hit process. It's worked a little bit harder, but it still didn't take long. And if I drag that in, here it is, globalatlas.tiff. So there you can see that it's clipped to that complicated polygon. We've outputted at relatively low resolution, but this system can also output arbitrarily large rasters at any resolution that you want. So let me close that one off, and let me close that one off. So going back into the export dialog, the only other thing to mention about this is the manual option. So if we go to full extent, here's the manual option. So in the manual option, you can type in the coordinate range that you want it to go over, and it will then. There are then ways to adjust the pixel size and the raster size after you've done that. So, for example, this button will then fit the raster size, a number of pixels, to the range that you've specified given this pixel size. Or if you hit this button, this will fit the raster size to the pixel size that you've just edited. And all of these other buttons do similar things in different combinations. So you just need to carefully choose which buttons to use to fit your pixel size or fit your raster size to the range that you're going to want, and then I'll export in that rectangular range. So that's the export dialog.